So in this video, we're going to talk about how to solve absolute value inequalities. So here's our strategy. An absolute value inequality can be solved by rewriting it as a compound inequality. So an absolute value inequality with a greater than or equal to sign will become an or inequality. An absolute value inequality with a less than or equal to sign will become an and inequality. So let's think about what this means and why this is true. So for example, if we think about the inequality, the absolute value of x is less than 4, what is that asking me? Well, it's saying figure out all the numbers x that are less than 4 units away from 0. So if we look at the right of 0, we can see that any number between 0 and 4 is going to be less than 4 units away from 0. On the left side of 0, any number that's between 0 and -4 is going to be less than 4 units away from 0. So if I shade in all those numbers that are possible solutions, notice I get this graph here. Well, when I'm looking at the graph, it kind of looks like the solution to an and inequality, right? Because I have two endpoints, and then I've shaded the region that's in between the two endpoints, which is exactly what we do when we're graphing an and inequality. And I can actually write an and inequality to represent this, right? So this is -4 less than x less than 4. So that's why we turn an inequality with a less than or equal to sign into an and inequality. So for example, the absolute value of x is less than 4 can be rewritten as -4 less than x less than 4. So on the other hand, what if we think about the absolute value of x is greater than or equal to 3? Well, that's basically saying, well, tell me all the numbers x that are more than 3 units away from 0. Okay, so where do we find those numbers? Well, numbers to the right of 3 are going to be more than 3 units away from 0. And numbers to the left of -3 are going to be more than 3 units away from 0. So if I shade in all those possible solutions, notice that this graph looks like an or inequality, right? Because I have two separate pieces that are graphed on the same number line. So I can write this as x is less than or equal to -3, or x is greater than or equal to +3. So that's why we turn an inequality with a greater than or equal to sign into an or inequality. So for example, the absolute value of x is greater than or equal to 3. I can rewrite that as x is less than or equal to -3, or x is greater than or equal to +3. So now we can summarize what we found here. Okay, so anytime we have a less than or equal to sign, and if we're talking about C, a positive number, we can rewrite it as an and inequality. If we have a greater than or equal to sign, and we have C, a positive number, we can rewrite it as an or inequality. So let's apply this to solving absolute value inequalities. So as always, just like we do when we are solving equations, we're going to start off by isolating the absolute value. Then once we've done that, we're going to look at the inequality sign to determine whether we have an and inequality or an or inequality. Remember that the inequality sign is going to determine this, right? So a less than or equal to will become an and inequality. Greater than or equal to will become an or inequality. Then we'll solve the compound inequality and then graph our solutions, and we'll write our answer using inequality and interval notation. So since we're going to be using interval notation, I just want to quickly remind you of what that looked like. Remember that a filled-in circle will be represented with a square bracket, and then an open circle will be represented with an open parentheses, right? So we can have open parentheses and square brackets in our intervals. Also remember that whenever we're talking about infinity, so negative infinity or positive infinity, we're going to use an open parentheses because infinity is an idea, not a number, right? And then if we have an or inequality, which means we'll have two separate pieces graphed on the same number line, we'll use the union symbol to join those two pieces together. So now let's work on some examples. So let's try solving the absolute value of 2x plus 3 is less than 5. So in this case, we already have the absolute value isolated. Okay, so we can just go ahead and turn this into an and or an or inequality. Well, I can see here that I have a less than sign, right? So a less than will become an and inequality. So I'm going to rewrite this as -5 is less than 2x plus 3, which is less than 5. So now I need to work on isolating the variables so that I can solve this. So I'm going to start off by subtracting 3 everywhere in this inequality. Okay, so when I subtract 3 everywhere, I get negative 5 minus 3, which is negative 8, and that's less than 2x, which is less than 5 minus 3, which is 2. Now to isolate x, I need to go ahead and divide everything by 2. So I'm going to divide all 3 parts of my inequality by 2. And when I do that, I have negative 8 over 2, which is negative 4, and that's less than x, which is less than 1. So that's my solution in inequality notation, and now I need to go ahead and graph my solutions. So when I graph, the negative 4 is going to have an open circle because of the less than sign, and the 1 will also have an open circle because of the less than sign. So now I'm going to shade all in between these two endpoints, and now I need to write my solutions as an interval. So remember, open circle means open parentheses, so I have negative 4, and then my other endpoint is positive 1, so that's how I write it in interval notation. So now you can go ahead and pause the video and try doing this example on your own. So in this example, the absolute value is already isolated, and we have a less than sign. So that less than is going to become an and inequality. So we can rewrite this as negative 3 less than x minus 1 less than 3. And then to solve for x, we're just going to go ahead and add 1 everywhere in our inequality. So that gives us negative 2 less than x less than 4. And when we graph this on our number line, we're going to use open circles at negative 2 and 4. And so that means when we write this in interval notation, we're going to use open parentheses at negative 2 and 4. Now let's try this example. Well, this example, I don't have my absolute value isolated, right? Because I have this extra fluff with it. I have this plus 4 right here that I need to work on getting rid of first. So I'm going to go ahead and subtract 4 from both sides. And when I subtract 4, I have the absolute value of 2x minus 3 is greater than or equal to 9 minus 4, which is 5. So now I have a greater than or equal to sign, so this is going to become an or inequality. So since it's an or inequality, I'm going to write this as 2x minus 3 is greater than or equal to 5, or 2x minus 3 is less than or equal to negative 5. So now I just need to work on solving these two inequalities. So to get x by itself, I'm going to start off by adding 3 to both sides. And when I add 3 to both sides, I get 2x is greater than or equal to 8. So now to solve for x, I'm going to go ahead and divide by 2. And when I divide by 2, I get x is greater than or equal to 4. So on the right side, I'm going to use the same steps, except I'm going to get a different answer. So I'm going to go ahead and add 3. And that's going to give me 2x is less than or equal to negative 2. And now I need to divide by 2. When I divide by 2, I get x is less than or equal to negative 1. So when I write this solution, I'm going to write x is greater than or equal to 4, or x is less than or equal to negative 1, right? So that's my compound inequality. So now I need to go ahead and graph my solutions. So when I graph my solutions, x is greater than or equal to 4. I'm going to put a filled in circle at 4, and then shade to the right of 4. So for negative 1, I'm going to put another filled in circle at negative 1 and shade to the left of negative 1. So now I need to write my solution in interval notation. Well, my solution's in 2 pieces, right? So I'm going to need to use that union symbol to join both pieces together. So let's start off with the left piece. So it starts off at negative infinity, so open parentheses for infinity, right? And then negative 1 is included, so I put a square bracket there. And then I have or, so I need my union symbol. And then I have square bracket for 4, and then that part goes to positive infinity. So that's my solution in interval notation. So now let's try this example. So once again, we have an absolute value that's not isolated, right? We have this 6 right here, so we need to do getting rid of our 6 as our first step. So to get rid of 6, well, remember that 6 is multiplying my absolute value, right? So the opposite of multiply is divide, so I'm going to divide both sides by 6. So that's going to give me the absolute value of x plus 2 is less than or equal to 36 divided by 6, which is 6. So less than or equal to is going to turn into an and inequality, right? So I'm going to rewrite this as an and inequality. So I have negative 6 less than or equal to x plus 2 less than or equal to 6. Now I need to work on getting the x by itself. So to get x by itself, I'm going to go ahead and subtract 2. So I'm going to subtract 2 everywhere in this inequality. And when I do that, I get negative 6 minus 2, which is negative 8, less than or equal to x, less than or equal to 6 minus 2, which is 4. So that's my solution in inequality notation. Let's go ahead now and graph our solution. So at negative 8, I have a filled in circle. And then at 4, I have another filled in circle, and I'm going to shade in between these two endpoints. So now let's write our solution in interval notation. So as an interval, negative 8 is going to have a square bracket, so I have negative 8, and then 4 is going to be another square bracket. So now let's try this example. So if I look at this, I see that I have a lot of things with my absolute value, right? So I have this 3 and I have this minus 6 that I need to work on getting rid of. Well, remember, whenever we're getting rid of the extra fluff around our absolute value, we always try to add or subtract before we multiply or divide in general, right? So usually that's what we do, and that's what's going to work in this problem. I'm going to go ahead and add 6 first, and then that's going to give me 3 times the absolute value of 2x minus 4 is greater than 18. So now I need to get rid of that 3. Well, that 3 is multiplying my absolute value, so I'm going to do the opposite. I'm going to divide. So when I divide both sides, I get the absolute value of 2x minus 4 is greater than 18 divided by 3, which is 6. So this is a greater than, so this is going to be an or inequality. So I'm going to write this as two separate pieces. So when I write this as two separate pieces, I have 2x minus 4 is greater than 6, or 2x minus 4 is less than negative 6. So I'm going to work on now solving these two inequalities. So I'm going to start off by adding 4 to both sides. And so that's going to give me 2x is greater than 10. And now to solve for x, I need to divide both sides by 2. And that's going to give me x is greater than 5. Now let's solve the other piece using the same steps. So I'm going to add 4 to both sides. And when I add 4 to both sides, I get 2x is less than negative 2. And now I need to divide both sides by 2. And that gives me x is less than negative 1. So now I need to write my solution. So I have x is greater than 5 or x is less than negative 1. And I'm going to now graph these solutions on my number line. So I have x is greater than 5. So open circle at 5 and shade to the right. X is less than negative 1. I have open circle at negative 1 and shade to the left. So now let's go ahead and write these solutions using interval notation. So the left piece, it's going to go from negative infinity to negative 1. Since negative 1 is not included, I'm going to use an open parentheses. And then for or, I'm going to use my union symbol. And then my other endpoint is 5, and it gets an open parentheses because it has an open circle. And that piece goes to positive infinity. So that's my solution in interval notation. So now you can go ahead and pause the video and try doing this example on your own. So in this example, you can see once again, we have a lot of stuff with our absolute value that we need to get rid of first. So I'm going to start off by getting rid of that plus 3, right? Remember, add or subtract before we multiply or divide. So I'm going to subtract 3 from both sides. And that gives me 2 times the absolute value of x minus 4 is less than or equal to 6. Then I'm going to divide everything by 2, which gives me the absolute value of x minus 4 is less than or equal to 3. Since it's less than or equal to, it's going to become an and inequality. So I have negative 3 less than or equal to x minus 4 less than or equal to 3. So if I go through and add 4 everywhere, I get 1 is less than or equal to x less than or equal to 7. So when I graph this on my number line, I'm going to get 1 and 7 as my endpoints, and I'm going to use filled in circle at both those endpoints. And then I'm going to shade in between because I have an and inequality. And when I write this in interval notation, my interval is going to go from 1 to 7, and I put square brackets at both endpoints because both endpoints are included. So remember, you can solve an absolute value inequality by turning it into a compound inequality. An absolute value inequality with a greater than or equal to sign will become an or inequality. An absolute value inequality with a less than or equal to sign will become an and inequality.